Hello students, welcome back. So finally we're going to look at composite solids. So composite solids, basically we have learned about all the various solids such as the cylinder, the prism, the pyramid, the cone, the sphere, etc. So sometimes they combine together to form another shape, right? And when they do that, we just need to actually read the question carefully and work out the parts individually. Okay, so down here there's a few vocabulary: additive and subtractive. So what does it mean? What happens is when I have one shape, add it to another shape, is called additive, right? So if I have one shape and I take out a certain part of it, it is subtractive. So in the two examples we have over here, the first one is additive, the second one is subtractive, right? If you look at the diagram, it can be quite clear. So anyway, let's look at the first example. Here we have a figure. It shows a closed container of a uniform cross-section. Sure, so it looks like this. Quite interesting. So what happened is we actually have a cuboid and it is added to a, there's a quarter of a cylinder, right? So we have something like that. Okay. So there's the dimensions are all shown in diagram. You can check them against the question and it makes sense, right? And we are told to find the volume. Right? So the first thing we're going to do, right, is to find the cross section, right? The area of the cross section is the useful information. So let's start with that, right? So I'm going to start with that. Area of cross section. Okay, in this case it will be 14 times 9. That will be the cross section for the cuboid. And then for the quarter cylinder, it will be a quarter times pi, and the radius is 14, right? Square. Okay, so we work this one out. The area of the cross section is 279.938 centimeter square. So we have the cross section, right? So the cross section is useful and it can be used to find both the volume and the total surface area, which is why we get this information first, right? So now let's find the volume. The volume, right? Let me scroll up. You should have read the question already. The volume now is equals to, right, the cross section multiplied by the length of the shape, which is 20, right? And you work this one out, you will end up with 5,600 cubic centimeter corrected to 3 significant figures. Right, so quite straightforward. The cross section times the length that will give us a volume. Now, as for the total surface area, you need a bit more calculation. Total surface area. Okay, if you remember how it works, we need 2 times the cross section, right, for the two bases, plus the perimeter, right? The perimeter, 14 plus 14 plus 9 plus 9, that's the perimeter. And of course, we have a quarter of the circumference, right? So a quarter of 2 pi r. So a quarter of 2 pi 14, right? So this is the circumference multiplied by 20, okay? So take your time. If you need to pause the video to examine the working again, you can do that. But generally, that's the idea. 2 times the cross section plus the circumference or the perimeter of the cross section, right? Let me highlight for you. Highlighted in orange, this is the perimeter of the cross section times the length, right? So from here, okay, we work this one out. It is 1920 square centimeter corrected to 3 significant figure. Okay, right, example B. Example B, we have a subtractive. So what happens is we have a cuboid and then a half cylinder is actually subtracted from it, right? So again, we are told to find the volume. So to do that, the first thing we're going to do is to find the area of the cross section, because useful information. So area of cross section, right? This time round, it is actually the rectangle 8 by 6 minus away half of the circle that of the missing cylinder, right? So half pi, and the radius is 3, half of 6, right? So square, okay, pi r square, right? Minus half pi r square. So this is our area of cross section. It works out to be about 33.8628. So from here we can find the volume. Volume will be equals to the cross section multiply with the length, which is 12, and that will give us 406 cubic centimeter corrected to 3 significant figures, right? Part 2, let me scroll up. Part 2, this time round we are told to find the total surface area. Okay, so same procedure, it will be 2 times the cross section, which we already found in the earlier part, plus we want the perimeter of the cross section now. So the perimeter of the cross section in this case will be 8 plus 6 plus 8 plus, well, half of the circumference, right? So half circumference is 2 pi r, so half times 2 times pi times 3, right? And you multiply by 12. Okay, so work this one out, you get 445 square centimeter corrected to 3 significant figures. Okay, so again, you can pause the video, take a look and see if the working makes sense for you. I hope you are able to visualize what's going on here. With more practice, I'm very sure most of you will be able to solve questions of this nature quite well, right? So all the best in your learning, and have a nice day.